Hi, welcome everyone. So thanks for joining us for our third session for the Evolution Wireless Digital webinars. So today we're going to go ahead and talk about all things Evolution Wireless Digital and the RF link. In our first webinar, we covered how all of the new advanced features here really make Evolution Wireless Digital one of the easiest systems to use on the market. In the second session, we kind of talked about all the things that make Evolution Wireless Digital sound so absolutely amazing, from the capsules and the elements to the actual technology that we have in there. And again, today we're going to cover the RF link. I am accompanied here by my colleague Kevin, all the way from Germany. So thank you very much. And it's very late there, so I appreciate Kevin being here with us today. And so let's go ahead and get into it. Before we start, I do want to point out that we do have a Q&A here. So if you have any questions, please put them in the Q&A. We'll be monitoring the Q&A there. And then, we'll try to answer some of them as we're going, and then we'll be able to answer some of the rest of them as we get towards the end. So let's get into it here. So let's talk a little bit about traditional RF systems, right? In order to know what Evolution Wireless Digital is doing that's so unique, we got to talk a little bit about what standard systems do, right? So the first thing that we always talk about with wireless microphones is why can't we just put them on any frequency or any channel that we want, right? And a lot of that has to do with interference, right? So we want to make sure that a wireless microphone is placed on an interference-free channel. And that way it ensures that it will operate properly, right? And now what we want to do with every system, including Evolution Wireless Digital, is do a scan on the system or some other device in order to make sure that we're finding this clean channel. Unfortunately, the static interference, whether it be digital television stations or the noise floor or something else, isn't the only thing that can affect wireless microphones, or isn't the only thing that creates interference. There is something called intermodulation distortion, and this greatly affects what we have available in terms of clean channels, and it makes for a lot of interference that can happen. Unfortunately, this stuff isn't there all the time. This happens in certain instances, and we need to make sure that we can calculate that. So if your system that you're using is susceptible to intermodulation, you need to make sure that you calculate out exactly where you're going to put all of your wireless frequencies, in order to make sure that you don't put them on top of a frequency that could be filled with intermodulation at some point during your performance. If you don't do that, if you just place them wherever, even if it's on a clean channel right now, when this intermodulation happens, the receiver has a really tough time hearing the wireless microphone, right? So because it has something else there that's talking. So a good example of that is if you're talking to somebody, you're essentially the transmitter, and that person you're talking to is listening and they're the receiver. If somebody else starts talking at the same time, even if they're talking lower, it's going to be much more difficult for you to be able to hear. And this can cause dropouts. It can cause noise into the microphone. And it's definitely something we don't want to do. So let's talk about what intermodulation is. So when two signals are applied to an electronic circuit, they can overload that electronic circuit and they can create new frequencies. So this wireless microphone that I have here in my hand, it has energy coming out of the antenna here and it's going in all directions, right? Now, if I have another wireless microphone, that one is also sending information out, energy out in all directions. Some of that energy will go up into this microphone. Some of this energy will go up into that microphone. When both of those frequencies are applied at the same time to those electronic circuits, the microphone itself will overload and it will generate all these new frequencies in the air. So if your system is susceptible to intermodulation, you need to calculate all of this. You need to find where are those frequencies going to be, because if I want to put a third microphone somewhere, I need to make sure I avoid all of these, right? So in an example where we have one wireless microphone on 500 megahertz, we have another wireless microphone on 501 megahertz. This is how we do the math to calculate out where it's going to be. You have second order, third order, fourth order, fifth order, sixth order harmonics, and they're all at different frequencies. Now, the second and fourth and sixth order harmonics, we don't usually care about because they will occur far outside where other wireless microphones can be. But the third order and the fifth order harmonics are right above and right below where your wireless microphones are. So in this example, you can see the third order harmonics are at 499 and 502. If I were to put another wireless microphone on those frequencies or very close to those frequencies, the intermodulation will interfere with those wireless microphones, causing them to drop out. As the microphones get closer to each other, more energy goes from one to the other, creating more of this intermodulation. And as they move further apart, that'll start to go away. I have a good example of this. I was actually at a theater show over the weekend, and they obviously did not do any frequency coordination for their systems, and their systems were susceptible to intermodulation. And so you're watching the beginning of the show, and the leads are, they're singing and they're doing their thing, and everything's great. And then all of a sudden, the chorus comes out on stage, and everything's still okay. All of a sudden, the chorus members get close to each other. Now they're generating intermodulation. And all of a sudden, the lead microphones are cutting in and out. They're dropping out. They're doing all sorts of stuff like that because they were not placed on appropriate frequencies. It was not calculated out, right? And so this makes wireless microphones complicated to use. It makes for a lot less things that you can do. And if you get enough intermodulation distortion, like if there's enough channels or enough energy, the entire noise floor can actually rise up. And it can get very, very difficult to place any wireless microphones. So let's go ahead and take a look at what this looks like live. I'm going to pass it over to Kevin here. So he's going to show you on his spectrum analyzer what some of these systems look like.
Yes, Greg, thank you very much. Let me stop the screen sharing so I can switch over to show you the system I'm using. Is it it? Yeah, that should be it. So what you see here is now I have 4 channels of G4 and 4 channels of EWD. What we're going to do is we're going to start with the analog part. And you see I have tuned them to 570, 571, 569, and 572. So they have all a megahertz spacing in between. This is much more easier to demonstrate the intermodulation. So what I do now is I'm going to share my spectrum analyzer. Switch that camera back. And now what I'm going to do is I'm going to start switching on those transmitters. And you should see on the screen now carriers coming up. So this is an analog carrier. This is a 30 milliwatt EWG4. What I'm going to do next is I'm going to switch on the next transmitter. And as said previously, it's spaced 1 megahertz apart. And what you can see now is once I get those transmitters closer together, there are more spikes coming up in the spectrum. These are the intermodulation products. They're basically virtual carriers. You can operate another system on those carriers, but as Greg mentioned, there is a possibility of distortion, there's a possibility of higher noise, and it greatly reduces the range because you have an interference below your carrier. Let's switch on the third. This is the third now, and let's switch on the fourth, and then I'm going to put them all together in a big pile, and you see what happens. So I have now 4 carriers. And I'm going to take them all in my hand and go a little bit closer to the antenna, and you see basically what happens. You create many, many other carriers, which are basically then unusable for you. This is the traditional way of an analog FM system. This is the reason why you have to calculate frequencies. You have to find the spaces in between those carriers, in between those intermodulation products. Okay, Greg, back to you.
Awesome, thank you. I'm gonna go ahead and share my screen again. Right, and so now that we know a little bit about how all systems work, and again, this is not specific to analog versus digital systems. This is about systems that can produce intermodulation and systems that do not produce intermodulation, right? So pretty much every system on the market, with a few exceptions, which we'll talk about here in a second, produces intermodulation, and now you have to avoid it. You need to either stick with banks and channels, or you need to do complex coordination to figure out where this stuff is. So now let's get to EWD, right? Now you have a little bit of an understanding of how traditional systems work. And let's discover what it is about EWD that really puts it into a category that no other wireless microphone is in at this price point. And it's really its ability to do an equidistant frequency grid. Now, we just talked about how doing an equidistant frequency grid by placing them 1 megahertz apart or any other, equal spacing is not a good thing to do if the system produces intermodulation. Well, again, with a traditional system that produces intermodulation, those intermodulation frequencies crowd the spectrum. They require complex coordination so you can avoid where those things are going to be so you don't get those dropouts. And it makes it so you can't put anywhere near as many channels. Well, with Evolution Wireless Digital, that is a thing of the past. And Evolution Wireless Digital eliminates intermodulation. So now, with no intermodulation, you don't have to avoid frequencies anymore because there are no other frequencies. They don't exist. This makes it much easier to use, which we talked about a couple of weeks ago, because now you don't need to be an expert to figure out where those things are, do complex math, or have some software doing it for you, or banks and channels. Even if you're doing a big system, it doesn't matter. You can just stick them right next to each other. This makes the environment a lot more clean, a lot more stable. It makes for the systems to be, more rock solid, and it also increases the channels that you can get drastically. And we'll talk about how many channels you can get with Evolution Wireless Digital here in just a minute. So why don't we jump back over to the spectrum analyzer and take a look at some Evolution Wireless Digital channels as opposed to the intermod channels that we just saw a moment ago.
Yes, let's do that. And here comes the scary part, because my entire professional life, I have been doing this, and I've always been doing frequency coordination and all these kinds of things. And this will be a thing for the past. I hope I'm not losing a job, but what you see now is basically, this is now one channel of EWD. It looks a little bit different than an analog carrier. It's a little bit wider. Reason for that is we're not looking only at the amplitude, we're looking at the modulation scheme and the noise coherence. So it uses a little bit more bandwidth. So here's the same thing. I have two transmitters now, and I'll try to have them crosstalk and overload the circuitry. So I go close together. There is nothing happening. So as you remember in the analog domain, this looks different, more like a Christmas tree. Let's add a third transmitter. And let me switch on the fourth transmitter as well. And we could go on like this forever. It's not limited to any number of channels. So I have them all together now. And as you can see, I can go a little bit closer to the antenna. But as you can see, it's a clean spectrum. It makes your life much easier. You do not have to worry about any coordination anymore or presets and banks. That's why we have eliminated this in EWD. Yeah, so this is how it looks in the digital domain. Much cleaner, much more easy to manage, and it allows you to concentrate on other stuff than frequency coordination. Greg.
Awesome. Thank you. It's really pretty amazing how clean it is and how different it is just from one system to the next.
Yep.
So one thing to note here is that there are only 3 systems on the market that are capable of doing equidistant grid. So that's the new Evolution Wireless Digital, Digital 6000 from Sennheiser, and Digital 9000 from Sennheiser. These are the only systems on the market that are intermodulation free. So there is a lot of misconception out there that this has to do with digital versus analog, and that is not true. Both digital and analog systems are equally susceptible to intermodulation. Digital 6000, 9000, and new Evolution Wireless Digital are intermodulation free. So that's a very big, thing that we want to make sure of. Is not really doesn't have anything to do with it being a digital system, and it really has to do with its extreme linearity, which we'll talk about here in a few minutes. Again, as Kevin said, this makes it so there are no more banks and channels. There is no more need to hook up to a computer and start doing complex calculations as long as you're using all Evolution Wireless Digital or Digital 6000 or 9000. It eliminates those intermodulation dropouts because there is no interference to interfere with your microphones anymore. So it makes it so much cleaner. And all you have to do is find any open, clean space and put the channels right next to each other, 600 kilohertz apart, and you can just keep going until you run out of spectrum. Now, how did we do that, right? You're saying, well, if they're the only systems, like how are you able to do that? It's due to its extreme linearity. So linearity really means that, it's how much energy is needed to overload that component, right? So EWD's components are resistant enough to distortion or being overloaded, and the amount of power output that they put is not enough to overload them, right? So between the combination of the high level of linearity and the power output that we're using, you can get an almost unlimited number of EWD channels in the same space, and there's not enough energy for them to overload each other. Therefore, they will operate without producing any of that intermodulation. Again, this is specific to Evolution Wireless Digital. digital 6000 and 9000, and has nothing to do with them being digital. So the one thing that we want to be very clear on is the carriers that are coming across on all wireless microphone systems from all manufacturers, regardless of whether they're analog or digital, are sending analog carriers and altering them in the analog domain. That's the only way that this can be done. The difference is in an analog system, we're representing a waveform by altering that carrier. And in a digital system, we're representing a pattern of zeros and ones or data coming across. But the systems, the energy coming out is still the same, and the carriers are still analog carriers. I don't think there's any such thing as a digital carrier. And so, you know, the amount of energy it takes to overload, or the reason that they overload each other, has nothing to do with it being analog or digital. Now, I will caveat that with, you can create an analog system with very low linearity components, and it will still work. A digital system does require you to use some level of linearity in order to make it work. So you'll never see a digital system that has extremely low linearity, because it won't work. But only 3 digital systems have enough linearity in order to eliminate intermodulation entirely. All right, so I did have a good question here, and I'd like to answer this one now. It says, what is the difference between EWD Digital 6000? So a big difference is that Digital 6000 is able to do this intermodulation free, even though it has a much higher output power. That's using some additional, very expensive components in order to do that and isolate that frequency. We use isolators in Digital 6000. There is also a lot of other features inside Digital 6000 that are not available in Evolution Wireless Digital as of today. So they're definitely still a tier up for Digital 6000, but we did bring a lot of the technology down into a much more affordable price point. All right, there we go. So let's talk a little bit more about some of the other features of Evolution Wireless Digital and its RF that make it really great. So first, we're giving you 56 megahertz of tunable spectrum per band. That is the most of any system at this price point, and more bandwidth is always going to be an advantage. Because of the equidistant frequency grid, and because we can get all those extra channels that we talked about, coupled with the amazing 56 megahertz of bandwidth, you can get over 90 channels in a single band if the entire band is wide open. It's actually around 92 channels that you could get. We have 2,240 selectable frequencies. You can select every 0.25 kilohertz within that 56 megahertz. So you have a lot of options to choose from there. And it's available in 3 separate bands in the North America market. So we'll have 3 bands available. If you're in a different market than North America, there are other bands available. There may be more or less bands available depending on what your local region is, and I'd contact your local Sennheiser rep, and they'll let you know what is available for the regulations in your area. So let's compare these bands a little bit to our previous generation G4 system. So the first band we're going to have is Q1 through 6. That goes from 470 to 526 megahertz. That means you can tune the system to any 0.25 kilohertz frequency from 470 all the way to 526. So this is very similar to our G4's A1 range. Obviously, we're giving you more bandwidth now, so you do have a little bit, you can tune a little bit higher than you could before. And it is a little bit smaller than the 300-500 series from G4, you know, which that one goes all the way up to 558. Now, do keep in mind, with even though we're giving you less bandwidth than the 300-500 series, we're at the price point of the 100 series, and you can still get drastically more channels in that bandwidth in the Q1 through 6. We then have R1 through 6, which is going to go from 520 megahertz all the way up to 576 megahertz, very similar to the A band, and right in between the AW plus and GW bands for the 300-500 series. And then we have the R4 through 9 band, which is going to be 552 to 608 megahertz. That is similar to the G band, but again, wider. And it's actually a little bit wider than the GW1 band we have available in North America for the 300 and 500 series. One thing I will say is you can mix and match here. So if you do have some R1 through 6 receivers and some R4 through 9 transmitters, in the frequencies that overlap, you can use them interchangeably. And you can a little bit as well with the Q1 through 6 and R1 through 6 in that small gap if you're in a pinch. Obviously, we recommend you pair your transmitters and receivers to the same band so you have the entire usable bandwidth. But if you're in a situation where you have an R4 through 9 receiver and an R1 through 6 transmitter, you can use them together in the overlapping portion. So let's talk a little bit more about bandwidth and why it's really so helpful, right? And the reality is that the more bandwidth you have, the more chance you're going to have of finding an open space. So as we all know, the spectrum that's available today is getting more and more crowded, especially here in North America. It's very, very crowded in some places. The chance of you finding that entire 56 megahertz open, unless you're in a super isolated building, is very, very slim. And so the more bandwidth you have, the more chance you have of finding an open spot. So like this parking lot that we have here, if you have access to the entire parking lot, you have a much better chance of finding a spot than if you only have access to part or some of the parking lot, right? And so it's really simple there. You just want to be able to find a spot for your wireless microphones, and there's a lot of other stuff in the spectrum like digital television, other wireless microphones, other interference, life safety systems, other things that maybe shouldn't even be producing RF, but they are because there's something not right with them. And so really you want to have as much bandwidth as you possibly can, and it yields more channels available to you, even if you're just trying to get one wireless mic. So a good example, if you have a system that's maybe 24 megahertz wide, there will be some places in the country that you go that that entire 24 megahertz will be filled with digital television stations, and you might not even be able to get one channel there. So having more bandwidth gives you more chance of finding open space. Again, 56 megahertz is the most of any system at this price point. So let's take a look at some of these systems on a spectrum analyzer, and let's look a little bit more into the bandwidth, right? So here are actually 10 channels of Evolution Wireless Digital, all within a 6 megahertz band there. And so we're getting 10 channels here, and we're only looking at 6 megahertz in this photo. If we zoom out to the full 56 megahertz, and this is a real world photo, we can see that we're only using up a very small portion of that. We see these big channels here, these 4 channels. Those are digital television stations. This is actually a scan of downtown Montreal. You also see there on the bottom left, there is some other interference that's happening. That might be a life safety system. That could be something else that was near the scanner or in the area. But even though this is a crowded spectrum with a lot of other stuff going on, Evolution Wireless Digital can still get over 50 channels in this space. You could get 10 in between, the gap to the left of each of those channels that we already have. You can get probably another 10 down at the bottom, maybe 7 or 8 channels where that interference is, and even a few more above since we have a little bit more spectrum to work with. So now that we're working with that equidistant grid and we're not worrying about intermodulation anymore, we can put a lot more channels. So a lot of people have said to me, well, 92 channels, I don't need 92 channels. How is that helpful to me? Well, when you go to the real world, it's always going to be reduced. You're never going to find a situation, again, unless you're in an isolated space, where you'll be able to use the entire spectrum. So a lot of times half or maybe 75% of your spectrum is filled. So if you're able to do equidistant grid and you have 56 megahertz to work with Evolution Wireless Digital, if 75% of your space is filled, you could still get like 24 channels, 23 channels in that space. With other systems, a lot of them with similar bandwidth or a little bit less, maybe 32 channels is the maximum. 75% of that becomes filled, and now you're down to only a few channels because you may not be able to place those where you want because of intermodulation. So it can drastically be reduced, and we still get a far higher channel count than other systems. Let's take a look now a little bit at the actual output power that we're using for Evolution Wireless Digital. So we've got 10 milliwatts of output power for the Evolution Wireless Digital system. And the one thing we want to be really clear on is that analog and digital systems are not rated the same way. So if you are comparing systems, you may see that Evolution Wireless Digital is giving you 10 milliwatts. Our 100 series previously was giving you 30 milliwatts. And at first glance, you may say, well, I'm getting a lot less power than I used to get, right? But in reality, you're really not, right? So an analog system and a digital system are rated differently. Digital systems are rated with an RMS style rating system. Analog systems are referring to the peak power output. So that's usually a 2-to-1 variance right there. That can vary, but traditionally you can double the power there for a digital system to get them closer to a similar type rating if you want to compare them back and forth. In addition to that, the amount of power that we need to make it from one side to the other is lower in a digital system. So we don't need as much energy to make it to the other side. So what that means when you put it all together is that if you look at the 10 milliwatts that's coming out of Evolution Wireless Digital, that is roughly equivalent in terms of the amount of range you'll get to a 30 milliwatt system from our previous generation. You get about the same range. So with the included antennas, you're going to get about 330 feet of range for an Evolution Wireless Digital. And we'll show you how you can get even more range than that. We do our walk test here towards the end. The other thing I will say about the output power is 10 milliwatts output power is very industry standard for systems under maybe $1,500 a channel. You'll be very hard pressed to find a digital system with more power that is lower than $1,500 a channel. So let's now look at the switching technology that we're using. And with Evolution Wireless Digital, we have a brand new type of switching diversity called intelligent switching diversity. So in order to understand this, let's talk a little bit about what diversity is in the first place, right? And this is really the use of two antennas. I will say that all systems, including Evolution Wireless Digital and all of our competitor systems, really require the use of two antennas to give the best possible performance. And now the reason for this is that, as we said before, energy is coming out of the wireless microphone. It's going everywhere. Some of that energy goes into the receiving antenna, and that's great, right? We get our signal there. But every once in a while, the sound will bounce off of something, whether it's the ground or a wall or something else, and it will hit the antenna 180 degrees out of phase. And when this happens, you get phase cancellation, and the signal will dip down for a moment while this is happening. The chances of this happening in two different locations at the same time is very, very slim. And this is why we put two antennas on a system. This is also why those two antennas need to be in different locations. If we put them right next to each other, then we could have that fading happen, and then there's really no point to having two antennas. With that said, if you have one antenna, the system will work, and it will work perfectly fine, but you will get dropouts from time to time. Depending on the space, it could happen a lot. It could happen every once in a while, but it is an eventuality. You will get dropouts in almost every location, except for maybe if you're in outer space and there's really nothing for it to bounce off of. So what we do in these situations is we actually take the best signal from both antennas, right? So we say, all right, sometimes antenna A is going to have that fading happen. Sometimes antenna B is going to have that fading happen. But if we switch back and forth, we can always get the best possible signal, and that's going to be really good. Now, this is not a new concept to Evolution Wireless Digital. This has been happening in lots of systems, and there's different levels of diversity that we do talk about in different systems. What's unique to Evolution Wireless Digital is the new intelligent switching that we have here. So with the digital system, we have a data stream that is coming across to the receiver, right? There's a constant stream of audio data that we have coming across with the time code. Now, not all of the data that's being sent is audio. There's other data there. There's battery information, there's headers, there's all sorts of other information that comes across. And there's small little gaps in between the audio. So what we do is intelligently track the audio. We figure out exactly where it's going to be, and we only allow the system to switch inside of those little headers. Now, they happen extremely often, and we can have them happen very, very quick. So the Evolution Wireless Digital can actually decide, okay, I'm going to switch the other antenna. Okay, now I'm going to switch back every 0.85 milliseconds. So that's less than 1 millisecond, which is a thousandth of a second. So extremely fast that it can do that. And now you're never going to hear an audio glitch or an audio, issue, because we're only switching in between those gaps. Another thing that's unique to Evolution Wireless Digital is we've suppressed the surge that happens when we switch from one antenna to another. This allows us to coexist with analog systems in the same rack. Not all digital systems, actually almost no digital systems, can live in the same system, in the same rack as analog systems, because when they switch back and forth, the little bit of a power surge that happens can interfere with those other channels, those analog channels. And so we've really done a lot to suppress that surge here and allow you to use Evolution Wireless Digital alongside your analog systems as well. So now that we kind of talked a little bit about the antenna diversity, let's talk a little bit about the antennas that are actually available. So inside the box of every Evolution Wireless Digital, you're going to get a quarter wave antenna. We also have larger half wave antennas available. And both of these antennas are going to give you an omnidirectional pickup. They're going to pick up all the way around the actual antenna itself. They're going to have a little bit of a null point at the very top and bottom. And again, the quarter wave antennas are included. The half-wave antennas are available for a low price of $29. That'll give you a little bit better range. And these are good starting points. Again, the quarter waves can give you up to 330 feet of range with Evolution Wireless Digital. The next antenna, and this is actually the antenna we're going to use for our walk test here, is our ADP-UHF, which comes in at $299, and this is going to be a directional antenna. So this is actually a brand new antenna that we released alongside Evolution Wireless Digital. Now, this antenna is not specific to Evolution Wireless Digital. It will work with all of our systems, even competitor systems as well. It's just a really great directional antenna. Got these new cutouts in it so it doesn't go flying in the wind, which was very, very helpful for me today, since you'll see when I go out there, it is quite cold and windy. But it warmed up a little bit from the earlier session we did this morning. And these give you directionality. So what they'll actually do is give you about 5 dB of forward gain in a single direction, and they'll attenuate some of the signal coming in from the back. It's really useful if you're trying to maybe point at where the microphones are going to be and kind of, reject away some of the outside interference. You might be able to get less digital television station and maybe have enough of a variance where you might be able to use some channels that you wouldn't be able to use with an Omni antenna. We do also have available our A1031 Omni antenna. So this is going to be a little bit bigger of an antenna than you get with those quarter or half waves. Similar omnidirectional pattern is going to come there. And they're great for being used as remote antennas. One thing I will say we have run into a few times, the quarter wave antennas do not have grounding planes on them. So you cannot take a cable connected to the end of a quarter wave antenna and essentially turn it into a remote antenna. You can do that with the half wave antennas or any of these other antennas that we have shown you here as well. Omni antennas are going to be really great in a situation where you're trying to pick up in all directions. So if you're in a theater and maybe you have, performers that go out into the theater and then they come in, Omni antennas, at the front of the stage might be a really great option because you'll get full pickup all the way around. They don't do a lot to reject out outside interference, but depending on your situation, if you have a lot of reflections, they could be beneficial, in what you're doing. And the last antenna we're going to show you is the A5000CP. This is a circularly polarized antenna. So this is essentially going to have a big steel plate in the back. It's going to prevent a tremendous amount of interference coming from the back and give you the most amount of forward gain to pick up, as far as possibly can. So you get about 10 dB of forward gain. Additionally, this is a circularly polarized antenna. So as your microphone moves around on a traditional antenna, your polarization changes a little bit, and that could affect the amount of signal that's coming into that antenna. The more reflections you have, the less of an issue it'll be. The less reflections you have, the more of an issue it'll be. With a circularly polarized antenna like the A5000, it actually eliminates that polarization because of this kind of corkscrew design, and really helps in terms of not mattering which direction your microphone is in. So the last couple of things we're going to kind of go through before we take a walk and see how much range we can actually get with this system is the new splitters that we have. So we have the brand new EWD ASA. This comes in at $599, and this is an active 4-channel splitter. So active means that the amount of signal coming in is the same as the amount of signal going out. So there is no signal loss here. And another cool feature about this is it will actually power the EWD receivers via the BNC. So you can plug a single power supply into the ASA, and then through the BNC, it will supply the RF signal, but also the power for the receivers. So a single power supply, again, will power the ASA EWD plus 4 of the EWD receivers. It will also power some of our G4 systems as well, which is pretty cool. The EWD ASA is not only compatible with EWD, it's compatible with all of our systems. It's actually the best splitter that we've made for all of our systems, and it will even work with third-party systems. Obviously, it's not going to power third-party systems through the BNC, but it will absolutely work as one of the lowest noise splitters ever made, and it's definitely the lowest noise splitter in its class. And that's one thing that we want to be very clear on. Not all splitters are created equal. They do introduce or can introduce a significant amount of noise to your signal. And so with the new EWD ASA, we really recommend using this for the new EWD system if we want to guarantee the highest possible level of performance. Now, a lot of people have asked us, well, what if I have an old splitter, or what if I have a splitter for another manufacturer? Will it work? And the answer to that is yes, it will work. But you may not get 100% of the performance out of the system. And depending on how much noise that splitter is introducing, whether it's a little or a lot, can pretty drastically affect the amount of performance you're going to get out of a system. So while we definitely know that almost all splitters will work with the Evolution Wireless digital system, we cannot guarantee that you'll get some of these amazing features out of it or the ridiculous range that we're going to show you here in just a second, because that additional noise floor can affect the intermodulation. It can affect your range. And so we'll do that. What I would recommend is if you already have one, give it a try. And if you get enough performance for what you're trying to do, then that's fine, right? If it reduces your range by 10%, but you only need 40% of your range, then that's not going to be a problem. If it is, hey, I'm not getting as much range as I really need to be getting, I'm really trying to get 330 feet out of this, and with that other splitter, I'm just not getting it, then that would be a great opportunity to upgrade to the EWD ASA. And in the future, we recommend the EWD ASA for pretty much any project you're doing, regardless of whether it's EWD or not, because of how really low noise this splitter is. I think we have a question probably about these splitters there. So here's a question that says, can the EWD ASA be daisy chained? And the question is, how many can we daisy chain? So the EWD can absolutely be daisy chained. You can connect two of them together to create an 8-channel system. You can then chain as many of those 8-channel systems as you want off of that, right? So if you put one 8-channel system on each of those 8 ports, that would give you 64 channels. And then if you went one more layer, put another 8-channel system on each of those 64 ports, that would give you 512 systems. You won't be able to get 512 systems in a single space because there's not enough RF spectrum to do it, and there's not enough bands to do it. But in terms of splitters, you could do it with the splitters. So essentially, you can have an unlimited amount of splitters chained to each other because you'll run out of available spectrum and channels far before you run out of too many splitters in a row. Cool. So the last thing we're going to talk about is the boosters that are available. So we have brand new EWD boosters as well, the EWD AB boosters. Again, these are the lowest noise boosters that we built in this type range. So really, really clean. They do the same thing as other boosters where they boost up the signal, but they do it with a very, very low noise, self-noise floor. Cool thing, they can be powered by the splitters or the receivers, and they give you 12 dB of boost. They are band specific, so make sure that if you're buying one of these, you're buying it specific to the bands that you're using for wireless microphones. And you want to make sure you place these at the antenna. Now, one thing we want to be very, very clear on about boosters is boosters are designed for one thing and one thing only, and that is to compensate for a cable that has too much loss. When you use a booster, you are increasing not only your signal, but you're also increasing the noise floor. So you only want to use a booster when you absolutely have to. It's always going to increase that noise level, and it's not really the best thing to do. So the first thing you want to do is see if you can get a cable that has a lower noise loss or lower loss cable. And you always want to be calculating out your cables, right? So depending on how long your cable is going to be, there are a ton of resources online or the cable manufacturers that tell you, hey, if I'm at specific frequency with a specific length, this cable will give me a certain amount of loss. For example, I have 25 feet of RG58 cable running to my ADP UHFs, which we're going to use here, and I get about 3.4 dB of loss. Now, I could have used a better cable to get less loss, which would actually give us more range in our test. Fortunately, I didn't have a different cable, so this is what we're going to use. But 3.5 dB is still going to get us a significant amount of range, which you'll see here in a minute. But if I was using 300 feet of cable, even if I use some of the highest level cable, LMR 400 cable or 9913 cable, it's still going to provide a significant amount of loss. And that's a situation where a booster is going to be able to boost that signal up and give us the appropriate thing. So first thing you always want to do is see if you can change the type of cable you're using or use shorter amounts of cable in order to prevent the need for boosting. But if you can't do that, then a booster can increase the range, and the new EWD ASA or EWD AB does a really great job at that. Okay, so I am going to go ahead and get ready for our walk test that we're going to do, and we're going to see how much range we can actually get from my EWD system, the one I'm using here. I'm going to walk down the street. Hopefully it's not quite as cold as it was earlier today. And while I'm getting my jacket on here, I will let Kevin answer a few of these questions.
Yes. We earlier in the webinar we stopped at 750 feet because Greg turned into an ice block. So I hope it's a little bit warmer now, wherever you are. Let's have a look at the questions. There's one coming in. I did not see a BRF output. It is a diversity system, so it has an A and a B output. You might have just missed it. The next question, so the EWD can automatically set the free requested frequency for each channel. The only set is the number of channel needed. I'm not quite sure what you mean, Fabio. Maybe you can specify that a little bit more. What I think is what you're saying is you just say I want 8 channels, and then the entire system does that for you. Well, you do have an auto scan feature where it looks for occupied spectrum, where it will basically then put a frequency in there. It will do this based on the amount of channels you have connected. Currently, with the EWD and the Smart Assist app, you can have, I believe, 16 channels. So this will do a coordination or a setup for 16 channels. Another thing, I don't know how much longer Greg needs. Let me quickly show you, because that question came up in our last session. This is the spectrum now, and you should be able to identify the carriers, the different carriers. There's 2 EWD carriers in here and 1 analog G4 carrier. And just to show you, the intermodulation is only happening on the analog side. You see on the left-hand side that tiny little blob, that carrier there. That is the EWD intermodulated in the RF circuitry of the G4 system. And I left the middle between the 2 EWD carriers empty, so you see there is no intermodulation coming from G4 into EWD. The coexistence, oh, he's outside. The coexistence is very simple. If you have to use a mixed system between analog and digital, you have to use a frequency coordination or banks and presets and apply it also to EWD. Or if you have enough space available, then just separate them. And as Greg already mentioned, the equidistant spacing, you just need to identify one spot in the spectrum which is empty, and you dump all your channels in there. It's really that simple. Okay, so let me stop this again. So we see the receiver. And now we have Greg walking in the cold. What you want to do is you want to watch the I'm colorblind, the green LED where it says link. As soon as this one turns red, there is a dropout, basically. Yeah.
So as you can see here, I've got my antennas set up and we're pointed down the street here. So I'm going to apologize right off the bat for me not being super steady with the camera. So if you get a little nauseous, please feel free to look away.
You need to
we're going to go ahead and see how much range we can actually get. I'll try to walk pretty quick. And we get down there. Now, those houses all the way down at the end there, those are about 750 feet away. So let's see how close we can get. This morning, we got all the way there. I also like to point out that this capsule is actually doing quite a great job. We have about 20-mile-an-hour winds here just south of Boston where I am. And probably you're not hearing any wind noise in there.
It sounds very clean to me, I must say. Also, what you can experience now is the advantage of having an external directional antenna. This gives you much more range, much more stable link in comparison to even the half wave dipole. That is an increase of the normal stick antenna, but having an external directional antenna will help you in these situations where you need to throw the carrier a long distance. Yeah, I'm not quite sure where you are.
Let's see where we're at. So we've still got pretty good signal here. And I would say we're about 350 feet or so. Let me go ahead and turn around, see where we came from. So this first block of houses down there, that's me.
Wow, that's pretty cool.
And we're still walking ahead. So we still have 2 to 3 bars, maybe hopping down to 1 every once in a while.
You're totally good. And that's another advantage of a digital system. In an analog FM system, you need to have roughly roundabout, it depends a little bit. Let's say 24, 25, 26 dB of carrier over noise. This is important to get the full audio signal to noise ratio. So if you want to have, for example, 110 dBA signal to noise, then you need to have 26 dB carrier over the noise floor in the RF domain. With a digital system, it's entirely different because the information is not stored in the amplitude, but in the phase of the carrier. You need around 10 to 11 dB over the noise. So that means you can have a much lower signal, and you still have CD quality audio just because it's digital. In the analog domain, you would start now to hear a little bit noise coming up, like swooshes and all these things, and that's simply because the signal to noise in the audio is massively dropping down because of the reception of the RF signal. In the digital domain, different
Yeah, so
story.
let's see if we're still getting
you're
pretty
still
good
at
signal
half
here.
Yeah, you're still very good, very good.
This is about 650 feet. If I get all the way down here,
I think that's pretty good. That's pretty good for that entry level system. I must say it's astonishing to me.
Yeah, I'll say we did get one time about 870 feet with these 2-directional antennas and a little bit shorter of a cable. So I'm going to go ahead and head back there. If there are any other Q&A,
head back. We didn't have any dropout. There was no. I don't think the error concealment was going. So this is all. You were on the safe side. And you must say you're outside Boston, if I understand this correct. So it's.
That is correct.
It is not downtown of a big city, but you are affected by a big city quite a lot.
We actually get all of the TV stations from downtown Boston because we're directly across the water. If I look down that way, you maybe see it all the way in the background.
While you are walking, I will answer a couple of questions. There is a question from Felix. He would like to know if there's interference if you rack mount a microphone system and a transmitter, like an in-ear system, in the same rack. And yes, Felix, you will transmit directly from the in-ear system into the microphone system if it's in the same range. If it's not in the same range, it might raise the noise level. So the recommendation is always separate in-ears and microphones. Even if you use external antennas and stuff like this, we are shielding our components on the inside, but nevertheless, it will radiate from the transmitter into the receiver. It's the same if you take a receiver and stand next to an SSL DSP engine from a mixing console, it will radiate directly into your receiver. There is
takes a long time to walk all the way back.
Yeah, you walked way too far. We have to make this different next time. There's another question regarding the B output. Maybe we are using a mismarked image, but in general, I can promise you it's not mismarked. There is a B output, and maybe the picture is not right. Wiring diagrams you will find, I believe, in the online manual, which you find on www.sennheiser.com.
So actually, when he's talking about that A output, he might be talking about the link output.
Yeah, that could be, that might be it. There's on each RF circuitry, A and B, there is a link output. So you can basically extend the system. Maybe you're meaning this. Could be. Did you take an Uber home?
Almost. All right. I am back here. Nice, warm studio. So let's go ahead and reshare my video here. Oh, that's not what I wanted to do.
That walk test is always very impressive, I must say.
Yep. As you can see, it's quite cold outside. My face is all red now. So, and I got my jacket on. So let's go ahead and just kind of go to the last thing we were going to talk about here, which is really our recap for the Evolution wireless digital system. If I can get it to go there. So we'll just kind of cover a little bit about all the cool features that are Evolution wireless digital. a lot of this we covered today, a lot of this we covered in previous sessions, but Evolution Wireless Digital is capable of 134 dB of dynamic range on the input. That is the most of any system, any wireless system ever made. And it's not just a little bit more than other systems. It's at least 5 times more than every other system on the market. We're able to do that equidistant frequency grid, which again, not only makes the system super easy to use, but it makes it more stable and better in the environment. We have Bluetooth sync now on the system, which not only allows for long range sync, but it also allows us to have a iOS and Android app that is free that you can download to control the systems, makes it super easy and does great for monitoring as well. The system deployment is super easy. We were able to set up 4 channels, scan, and do brand new frequencies and sync all in under a minute. I believe we did that in the first session. We have the intelligent switching diversity, which again is unique to the Evolution Wireless Digital. 24-bit pristine digital audio, best sound quality in its class, comparable to the best possible systems or most expensive systems. The most bandwidth of any system for the price, 56 megahertz. We're able to get over 90 channels within that 56 megahertz if it's wide open. That's not just a little bit more than every other system. That's a lot more. We have those 3 different frequency bands available in North America, other bands available in other locations. The system has 1.9 milliseconds of latency. That matches the lowest latency of any system on the market, and it is by far the lowest at this price point. We have that 10 milliwatts of output power, which obviously can get you plenty of range. We just went about 700 feet outside in a super windy environment. We have lots of system sets available. We have lots of new distribution accessories. We even have new lithium ion batteries. You can use AA batteries with this, which will get you 8 or 9 hours. Our lithium batteries will get you up to 12 hours of battery life. And we have that extensive selection of capsules, elements. This is a 435 capsule. And as you could hear, it was 20-mile-an-hour winds outside, freezing cold, and you couldn't even hear the wind at all. That's how much rejection we're able to get on there. So all those things together really put Evolution Wireless Digital, again, in a class that no other wireless mic has been in, especially at this price point. We are happy to hang out for a few minutes, answer any questions you might have, pop them in the Q&A. You're welcome to hang out with us and see what questions might come in. Otherwise, have a wonderful day. Thank you for coming and checking out the new Evolution Wireless Digital system. I hope you guys got something out of it. I will also put my email address in the chat for everyone to see. If you have any other questions or need anything, you can always reach out to me as well. So I'll put that in here. So while we're doing that, there's actually one question that I saw come in, and it was actually from a colleague of ours about when we were talking about, when I had that story about the theater, and saying, hey, when the chorus got together, they were, you can almost see the intermodulation happening because as they got together, the microphones are dropping out. And he kind of joked in there, hey, did you help them? Now, here's the thing. When you're at that point in the middle of a show, there's really nothing you can do, right? Other than maybe tell people to try to stay further away. Otherwise, you'd have to do a full frequency coordination. You have to stop the show. You'd have to bring everybody, resync all the transmitters. There's nothing you can do. So you really have to make sure that you either set up that frequency coordination properly before the show starts, or just have a system that doesn't have intermodulation, and then you don't have to worry about it. So let's go ahead and take a look at some of the Q&A that came in here. So the first question is, Dante coming soon. So one thing we have been very open about is that this is the replacement for our Generation 4 100 series. If you're familiar with our Generation 4, you know that there are higher variants than the 100 series. Those replacements will be coming in the future, and there will be many new features coming along with them. So while it may not be a direct answer, you're definitely going to see some really cool stuff in the future. So there's another question here about the app functions. So in our second webinar, Fabio, if you want to send me an email, we did kind of go through in depth the app, or maybe that was actually the first webinar we went in depth the app. We could send you a link to that video. We go through every single function and feature of the app. So the next question I got here from Thomas, how many capsules are there to choose from? So if I can remember off the top of my head, I believe there are 14 capsules to choose from, but all of our modern capsules work. So all the 800, 900 series, 9000 series, MD 400 series, and Neumann capsules will work. So basically all the capsules that are for current systems will work. The only ones that don't work are some of the ones specific to older wireless variants.
It's 12 Sennheiser capsules and 2 Neumann capsules.
There you go, 14 capsules. That's good. I'm glad I remembered that. So next question here is it possible to get an EWD IEM in the future? So definitely something that we're looking into. But the one thing to remember is that latency on an IEM system is definitely an issue. So this may be the first platform that it is low enough, and we're definitely looking into it, but no immediate news on that here. Cool. So those are the questions that came in. We did have one question about the webinars being available. I do believe, Kevin, you said that they all become available, the videos become available on our website at some point, or
Yes.
you can email me and I can send you a link to the video. So happy to hang out here for another couple minutes. If you guys have any other questions coming in, pop them in the Q&A. We'll hang out for another minute or two. If not, have a great rest of your day.
Well, thank you everyone from my side as well.